Greetings, traveler. I am the calculus clerk, and today we'll be going over infinite series. Specifically, if the series Cn multiplied by x to the n converges for x is equal to 6, then which of the following must be true? They list off three options 1, 2, and 3. But first, let's focus on this series. So they tell us it converges for x is equal to 6. Now you might be wondering, what Cn is. Basically, Cn can represent either a sequence like a of n, or it can also represent a number, or as you would call it, a constant. So you might be panicking right now because there's no way we can find C of n because it can literally be anything, but that can also be turned to our advantage because it can literally be anything. So, as long as we keep C of n the same throughout all of our tests, we can manipulate the value of C of n to give us an answer that would make it a lot easier for us to solve for convergence of x is equal to 6. So, if we keep Cn the same, we want to set Cn to some value like 1 over 6 to the 2n. The reason for that, I will illustrate now because we're only given that it converges for x is equal to 6. So replacing c of n with something like 1 over 6 to the 2n multiplied by 6 to the n will work to our advantage because, as you can see, this is basically a geometric sequence, and we can use the infinite geometric series rule to solve whether it converges or not. So how we do this, we need to isolate so it's somewhat like that format. So we need to have two numbers, like a fraction on the inside that's smaller than 1, all surrounded by to the nth power. And so we can restructure this by getting 6 and 6 squared, put that on the inside, and factor out an n from both of those terms. And that will give us 1 over 6 to the n. And 1 over 6 is clearly a number that's smaller than 1. And so by the infinite geometric series, this series will converge. Okay, so now we know our C of n, we have to keep it the same throughout all of our tests when we plug in x is equal to negative 6, x is equal to negative 3, and x is equal to 8. So we do this by simply just replacing the 6 or the x with negative 6 first. So we're testing for number 1. Okay, so negative 6. We can do the same thing, factor out the n, giving us this in the term of the infinite geometric series format. And that's equal to this. We can factor out the negative symbol in the front. So negative 1 to 1 over 6, the n. This might be a format you're more used to. This is an alternating series. And to prove whether it converges or diverges, one of the best ways to do this is take the absolute value of this whole thing, because by absolute convergence, if a said series converges absolutely, which means when we take the absolute value of it and it converges, then the original series will converge. So when we take the absolute value, this will normally alternate between negative and positive, but because we absolute value it, it'll only be positive. So we basically just slash the negative 1, just get rid of it. Then I'll leave us with that, which, as we know from the previous example, converges by infinite geometric series. Therefore, the original function that we took the absolute value of will converge as well. Okay, so we know that this works. Number 1, because we said that it converges for negative 6, and indeed, this statement says it does. And so for the next one, we'll basically replace x with negative 3 now. And same process, turn it into a geometric series. 3 over 36 is 112. Factor out the negative 1. First, we need to take the absolute value again. Jump the gun there. But as you see, it leaves us with 112, and so this converges by infinite geometric series again, because 112 is smaller than 1, so therefore the original series also converges. Okay, so we know the second one and the first both work. And now for the third and final result. Replace x with 8 now. 2/9. Well, this by infinite geometric series converges because 2/9 is smaller than 1. So let's look at the statement. Well, the statement says the series will diverge for x is equal to 8, but as we just proved, it converges. So therefore, this statement is wrong and it cannot be 3. So our answers are 1 and 2 will be true.